Hello and welcome to our channel, guys. Today we're going to study oxidation of alcohols. First, let me take you over the overview so we know what we're going to study in this video. First, we'll cover oxidation of primary alcohols. When does it give you RCHO and when will it give you RCOOH? That is, when will a primary alcohol on oxidation form an aldehyde and when will it form an acid? We'll also study different kinds of oxidizing agents, exceptions, which are really important for exams, and some examples. Next, we'll cover oxidation of secondary and tertiary alcohols, and after that, we'll see some example questions which are usually asked in IIT, NEET, and other competitive exams. So let's get started. First, we are covering oxidation of primary alcohols. The general formula for primary alcohol is RCH2OH or HCH2OH, where R is the alkyl group. Whenever primary alcohols are oxidized, they will give you one of the following products. They'll either form an aldehyde or they will form an acid. Now, one thing to remember is that when primary alcohol oxidizes to an aldehyde or even an acid, the alkyl group attached to the functional group does not change. You can see that R remains the same. Only CH2OH changes to either CHO or COOH. So now the major question of when is aldehyde formed? Primary alcohol oxidizes to an aldehyde in the presence of a mild oxidizing agent. Very simple. So I'll give you the names of the most popular mild oxidizing agents which are usually asked in exams. Number 1 is Fenton reagent, which is FeSO4 and H2O2. Then Saritz reagent or PCC, which is pyridinium chlorochromate. Jones reagent, H2CrO4 and acetone. PDC, which is pyridinium dichromate. Next is MnO2 and CH2Cl2. Then copper at 300 degrees Celsius. And the last is aluminium tertiary butoxide with acetone. So these are 7 mild oxidizing agents which are usually asked in exams. If they are present, then primary alcohol will oxidize only to an aldehyde, not to an acid. Now, related to what we've just studied, we're going to discuss a very important exception under target star point number 1. 5 out of the 7 reagents we've just studied, which are Jones reagent, PCC, PDC, MnO2 and CH2Cl2, and aluminium tertiary butoxide with acetone, these 5 oxidizing agents oxidize the primary alcohol without affecting any multiple bonds in the molecule. It is very, very important. So you have to remember that these 5 oxidizing agents, whenever they oxidize a primary alcohol, they do not affect the multiple bond. Let's see an example. CH3, CH double bond CH, CH2, CH2OH. In the presence of A, where A can be any of the 5 exception oxidizing agents which we've covered above, will give you CH3, CH double bond CH, CH2, CHO. You can see that only CH2OH, which is the functional group of primary alcohol, has oxidized to CHO, which is an aldehyde. The double bond remains unaffected. Now we've studied that when does primary alcohol form an aldehyde. So the next obvious question is, when does primary alcohol oxidize to an acid? First, primary alcohol forms an aldehyde and then it further oxidizes to an acid. So only a strong oxidizing agent will be able to oxidize a primary alcohol to the level of an acid. So the answer is very simple, in the presence of strong oxidizing agents. So again, let me give you the names of popular strong oxidizing agents which are usually asked in exams and are covered under curriculums. Number 1, KMnO4 in the presence of a base. Number 2, KMnO4 in the presence of an acid. Then K2Cr2O7 in the presence of an acid, concentrated HNO3, and Ag2CO3. In the presence of these strong oxidizing agents, primary alcohol oxidizes to carboxylic acid. Here there are no exceptions. So now for clarity, let's solve a question so we understand this concept better. We'll take a molecule CH3CH2 CH2OH. In the presence of A, it is forming CH3CH2CHO, and in the presence of B, it is forming CH3CH2COOH. So it's very simple now. You can easily answer this question after what we've studied above. A is a mild oxidizing agent and B is a strong oxidizing agent because B oxidizes the primary alcohol all the way to an acid. It does not stop at the aldehyde. Next, we'll cover the topic of oxidation of secondary and tertiary alcohols. It's really simple. Secondary alcohol, also called 2-degree alcohols. The formula is a central carbon with 2 alkyl groups attached to it, and then of course the hydroxy group attached to it, where R is any alkyl group. Secondary alcohol has no fuss on oxidation. It gives you only one product, which is a ketone, always and always. Doesn't matter what the oxidizing agent is, it will always give you a ketone as a product on oxidation. The attached groups will not change again, only the functional group will change from secondary alcohol to ketone. So you can either use mild oxidizing agent or strong oxidizing agent, doesn't matter. Both of them will give you the same result of the formation of a ketone. So for example, CH3, CHOH, CH3. So when that is oxidized, it will give you CH3, COCH3. Moving on to tertiary alcohols, you need to know tertiary alcohols are not oxidized easily by oxidizing agents. That is beyond most curriculums. So that's a very advanced topic. Generally, tertiary alcohols are not oxidized by these oxidizing agents which we are studying. So now let's solve a competitive exam question. Now that you've understood the concept, I'm sure you'll find this very easy. So if the question is, which is the best reagent for the following reaction? And the molecule is CH3, CH2CH, double bond CH, CH2, CH2OH, which is a primary alcohol. In the presence of A, it will give you CH3, CH2, CH, double bond CH, CH2, CHO, which is an aldehyde. Primary alcohol is oxidizing to an aldehyde, so obviously it's a mild oxidizing agent. And the double bond remains unaffected, so it is one of those 5 mild oxidizing agents which we had studied under exceptions. So the answer is PCC. The other 3 options are strong oxidizing agents, so they would form an acid and also affect the double bond. Congratulations. I hope this concept was clear to you. It always seems so easy once you've understood the concept. In case you have any doubt, you can ask them in the comments below. Thank you so much for watching this video. If you like the video, please hit the like button, subscribe to our channel. We'll see you next time. Bye bye.